We are the Gujarat Technological University. Since its inception over a decade ago, GTU has been empowering young and curating minds to realize their true potential. Over 4 lakh inspired students are enrolled with one of the premier academic universities in India. With more than 450 affiliated colleges in its fold operating across 5 zones of the state, GTU, the International Innovative University, your place to move forward.
Okay, in this problem, your data end projector of line PQ is 35 mm apart. So distance between end projector is equal to 35 mm. The end P of the line is 10 mm above HP. So point P is 10 mm above HP and 15 mm in front of VP. Okay, the front view and top view of the line measures 50 mm and 60 mm. Okay, so front view length or elevation length is equal to 50 mm and top view length or plan length is equal to 60 mm. Okay, so we have this 5 data. Okay, first I draw one reference line at here. Now first I present the point P. Okay, point P is 10 mm above HP. So from here I measure the distance 10 mm and it's 15 mm in front of. So if I take the 15 mm distance at here. Okay, so I get my P dash point at here and P point at here. Okay, so first I draw the locus for these 2 points, P dash and P. Okay, now distance between end projector is 35 mm. Okay, so here I measure the 35 mm distance and draw one vertical line. Okay, now its front view length is 50 mm. Okay, so for finding the point Q dash I have 2 conditions. Its distance from point P dash is equal to front view length 50 mm and I get the point on this vertical line. Okay, so I take P dash as a center, okay, and 50 mm as a radius. I draw one arc which intersect this vertical line at here. Okay, so here I get my point Q dash. This is my final front view. An angle made by front view is apparent angle alpha. Okay, similarly for top view length is 60 mm. So for finding the point Q I have 2 conditions. Okay, its distance from point P is equal to 60 mm and I get the point Q on this vertical line. Okay, so I take P as a center and 60 mm as a radius. I draw one arc which intersect this vertical line at here. Okay, so this is my final top view. An angle made by top view is apparent angle beta. Okay, I take P as a center and top view and 60 mm as a radius. I draw one arc which intersect this vertical line at here. So here I get my point Q. Okay, so I draw the locus at here for point Q. Similarly for Q dash. Okay, so I have 4 locus now. Okay, now from front view length I draw the arc. Okay, because we require to find the true length. Okay, here given that to find the true length. Okay, so for finding the true length, first I draw the arc from here. Take P dash as a center and Q dash as a radius. I draw one arc at here. I give the name Q2 dash at here. Now from this line I draw the projection. Okay, so joining this point I get my true length. Okay, if I measure the true length then it's equal to 70 mm. Okay, true length is equal to 70 mm. See, now I take the 70 mm as a radius, P dash as a center. I draw one arc which intersect the locus at here. Okay, so here true length. So here I get to my point q1 dash. Okay, this is the length, true length is equal to 70. Okay, and this angle made by true length is equal to theta. Similarly here, this angle made by true length is equal to phi. Okay, if I measure the angle phi, then phi is equal to 43 degree and theta is equal to 30 degree. Okay, theta is equal to 30 degree and phi is equal to 43 degree. Okay, that asking question. Okay, so I finding the true length by another way. Okay, from here PQ line, okay, P as a center and PQ as a radius, I draw one arc which intersected here. Okay, I give the name Q1 at here. Okay, now from Q1 I draw projection which intersected here. Okay, so I get the Q1 dash point at here. So I finding the Q1 dash, and now I connect the P dash with Q1 dash, so I get the true length. Okay, so I find the true length any of this method. You can also find alpha and beta. Okay, we get the alpha at here and beta here. Okay, so in this way we solve this problem. Okay, in this problem data given that the front view and top view of the line MN is inclined at an angle of 30 degree and 40 degree respectively. Means the angle made by front view is inclination angle alpha, which is 30 degree, and the angle made by top view is inclination angle beta, which is 40 degree. Okay, then the front view of the line MN measure 50 mm. So front view length or elevation length is equal to 50 mm. The point M is 15 mm above HP, 15 mm above HP and 10 mm in front of VP. Okay, so this phi data is given. Okay, so first I draw the reference line at here. Now first I mark the point M. Okay, for M point is 15 mm above, so from here I measure the 15 mm distance and 10 mm in front of, so here measure 10 mm. So I get my M dash point at here and M point at here. Okay, so first I draw the locus. This is the locus for M dash and this line is locus for point M. Okay, because we first find the four locus. Okay, now here front view length is given. Okay, front view length is 50 mm. Okay, and angle made by front view length is 30 degree is given. So I take 50 mm length at angle of 30 degree. Okay, so first I take 30 degree angle, 30 degree, this alpha. Okay, and length is equal to 50 mm. I draw one line at angle of 30. So here I get my point N dash. Okay, so this is my final front view. Okay, now another data is angle made by the top view is 40 degree. Okay, so from M point I measure the angle and I draw one line. Okay, I measure the angle and draw one line here. Beta is equal to 40 degree. Okay, here angle made by the top view is 40 degree. Okay, so I take the 40 degree and draw one line at here. Okay, I don't know where my point N, but I know that my point N is on this line. Okay, so I simply first draw line at angle of 40 because it is an angle made by the final top view. Okay, now here I present all the data. Okay, now here from front view length I draw one arc. Okay, because we draw the arc from the front view and top view length. Okay, so for here I draw one arc at here which intersected here. Okay, here I give the name N1, N2 dash. Okay, so this is my front view length, which is similar to this. Okay, which is given 50 mm. Okay, here we have not locus of N. Okay, so if I take the projection from N2 dash, I don't know where it intersect. Okay, so but we know that N dash and N point on the same vertical line. Okay, so from here N dash point I draw one vertical line, which intersect this line at here. Okay, so here I get my point N. Okay, because for end point I have two conditions. I get the end point on this vertical line and it's at an angle of 40 degree. Okay, so here I get the end, and this is my final top view. Okay, so here I get my fourth locus of n. Okay, and here I have locus of n dash. Okay, so now from n to dash I take the projection which intersected here. Okay, here I give the name n2. Okay, so here I have my top true length. Okay, so here I have my true length. This m and 2 is my true length. Okay, and now I have the true length, so I take this much as a radius and m dash as a center. I draw arc at here. Okay, so here I draw the true length and I give the name at here n1 dash. Okay, and this angle is theta. Okay, this is the true length make with the horizontal. So you find this true length by another method, by taking the arc from this top view. I take the arc at here. Okay, so I get the top view length at here. Now from this line, if I take the projection, it intersected here. Okay, so you find the true length by any of this method. Okay, in this problem, a line AB 90 mm long, so true length is equal to 90 mm is given, is inclined at 30 degree to HP, so theta is equal to 30 degree. Its end point A is 12 mm above HP, 12 mm above HP, and 20 mm in front of VP. Okay, its front view measures 65 mm. So here front view length or elevation length is given is 65 mm. Okay, so we have 5 data at here. Okay, let's solve. First I mark the point. It is our method is same. First we find the 4 locus, and then from true length I draw the projection, and from front view length and top view length I draw the arc. Okay, so first I mark the point A. Okay, so A is 12 mm above, so from here I measure the 12 mm. First I draw the reference line. Now here I measure 12 mm and 20 mm in front of, so at here 20 mm. So I get my A dash point at here and A point at here. Okay, so first I draw the locus for A dash. This line is locus for A dash and this line for locus for A. Okay, so I get 2 locus. Now under condition given, true length is 90 mm, it's make an angle 30 with HP. Okay, it's make an angle with HP, so we represent on vertical plane. Okay, so I take 90 mm as a length and draw line at angle of 30 degree. Okay, so here I measure the angle theta is equal to 30 degree and draw the line length is equal to 90 mm. Okay, so here I get my point B1 dash. Okay, and we know that the B1 dash and B point on the same horizontal line. Okay, so here I draw the locus. Okay, this is the locus for B dash. Okay, this is locus for A dash, and this line is locus for A. Okay, so I get my B dash point on this line. Okay, now here the front view length or elevation length is given 65 mm. Okay, so for B dash point I have 2 conditions. I get the B dash point on this horizontal line, and its distance from point A dash is 65 mm because front view length is 65 mm. Okay, so I simply take 65 mm as a radius and A dash as a center. I draw one arc which intersected here. Okay, so here I get my final front view A dash B dash. Okay, this is my front view A dash B dash, and angle made by front view is apparent angle alpha. Okay, so this data is given, so first I represent all the data given. Now from true length I draw the projection up to the locus of A. I get the projection of A dash point at here. Okay, so I draw the projection of B1 dash up to the locus of A. Okay, so here I get my top view length or plan length. Okay, now from top view length I draw the arc. Okay, so I given the name at here B1. Okay, so but here I have no locus for point B. Okay, but we know that the B dash point and B point on the same line. Okay, so from here B dash point I draw one vertical line Okay, as we seen here that the B dash point and B point on the same line, on the same vertical line. So from B dash point I draw one vertical line, so I get my B point on this line. Okay, so now for finding the point B, I have two conditions. I get the B point on this vertical line and its distance from point A is equal to top view line. Okay, so I take A as a center and A, B1 as a radius. I draw one arc which intersected here. Okay, so here I get my point B. Okay, so this AB line is my final top view. An angle made by this top view is called apparent angle beta. So here I get the locus of point B. Okay, so I get the true length on this line, end of the true length on this line. Okay, so I know the true length is equal to 90 mm. So I take A as a center and 90 mm as a radius. I draw one arc which intersect this locus. Okay, I take A as the center and 90 mm as a length. I draw one arc which intersect the locus at here. Okay, so here I get my point B2. Okay, so this is my true length. An angle made by true length is indicated by phi. Okay, so I finding the true length in another way. Here from front view I draw one arc at here. Okay, so I get front view length at here. Now from front view length, if I take the projection, it's intersect the locus at here. So here I get my B2 point. Okay, so I find the true length by any of this method. Okay, so in the question given that we require to find the top view of the line AB. Okay, so here we get the top view of the line AB and its length. Okay, so if we measure the line AB, then length of line AB is equal to 80 mm. This length is equal to 80 mm, and also determine its inclination. Okay, so inclination beta, inclination of the top view length is called the beta, which is equal to 55. Okay, this angle is equal to 55 degree. Here we also find the angle phi. Okay, which is true length make with the vertical front. If we measure angle phi, then phi is equal to 45 degree. Okay,